Hey everyone, this is an introduction to NATS streams and services on Kubernetes. My name is Waldemar Quevedo. I'm one of the NATS core maintainers. I currently work at Synadia Communications, where many of the NATS core maintainers are working. I've been using NATS-based systems for a number of years, almost for 8 years already. And I wrote a book about NATS, practical NATS. Which was released a couple of years ago, covering many of the core concepts of using NATS. So in this talk, I want to briefly cover what is NATS. It's going to be an introduction. We'll talk about some of the abstractions when you talk about NATS, which are streams and services. Talk about the different network topologies that you can form by using NATS, what we call the adaptive edge architectures, and also give a couple of demos of using NATS clusters and deploying with Helm on Kubernetes, followed by questions. So what is NATS? NATS is 10-year-old this year. It's a very battle-tested system, cloud-native messaging system, made for developers and operators that want to spend more time doing their work and less time worrying about how to do messaging. What distinguishes NATS is its performance, the simplicity, security, and availability trade-offs that are implicated in the design. It has multiple qualities of service, has above at most once delivery and at least once delivery. Thanks to the simple protocol, it has multiple communication, multiple client implementations, and it supports multiple communication patterns. We joined the CNCF last year in 2018. Under this, in the landscape, CNCF landscape, you can see NATS under the streaming and messaging section, next to gRPC, for example. And since the NATS contributions are ramping up for a few years already, has dozens of contributors, many NATS public repos. Also over 50 million downloads for the NATS server, NATS streaming server images. The Slack community is also increasing, continuously increasing. NATS v2 was released a couple of years now, but so we're currently on the 2.17 version of the server. The performance is still pretty fast, 18 million messages per second in a single server. Many times a single server is all it takes. If you use multiple data streams, you can even get it to 80 million messages per second with a very beefy machine. And NATS is a single binary. It has no other dependencies. It's very lightweight Docker container. Just 8 megabytes. The protocol, which has almost not changed in this almost a decade from NATS. It's very simple. Text-based protocol. You can just use the telnet to type in the protocol and interact with the system. It doesn't take a lot of configuration. It just should just work by default. And the API is very straightforward. Just publish, subscribe. One of the cool things from NATS is that there's a gossiping of the topology. So you just as nodes join and go from the system, they will their clients will gossip each other about the network endpoints so that they can use to failover. As I mentioned before, has at most once delivery for the core system, but you can also have at least once delivery by using some other submodules such as NATS streaming and also the Jetstream, which is another take on NATS streaming or the persistence of messages in NATS that is in the works right now. And NATS v2, a couple of very good features, interesting features that made it are the authority and authorization schemes. You have things like end keys, which are like private and public based authentication, also decentralized identities using JWTs. You can also have use the SANs from the TLS certs for auth, as well as a SVIT from SPIFFE certificates. Also, the NATS system became a multi-tenant using accounts, have account isolation, or so you can have namespaces for the subjects, and also have multiple network topologies, so it's more flexible. And we call them not only cluster connections, that has gateways and leaf node connections that we'll talk about them in a bit. And also WebSocket support has landed already. So NATS is at its core is a publish subscribe messaging. When we're talking about the APIs from NATS, you can do a request reply, which is one-to-one, sending a message, expecting a response back. You can do publish and subscribe, which is receiving end messages. Well, have an end number of consumers receive the message. And you can also enable load balancing of these subscriptions. Request replies works by having an inbox to each one of the messages that the other subscriber can use to respond. So yeah, at the API level is you have a subscription and ASIC handler, and you can respond into that message. Whereas publish subscribe, you can continue to publish messages, and then an end number of subscribers will receive it. And again, at the API level, you just subscribe on a subject, then receive a message, and use publish on foo, you will receive that message. You can enable load balancing for any of them, where only one member of part of that group will receive that message. So you can do create queue groups where you can share the work, distribute the work among a group. The API for that is queue subscribe, and it's very similar just to subscribe. You can also have wildcard support. There are two different types of wildcards. You have asterisk, which is matches on a single level of the subject, and you also have the greater than or full wildcard, which will match all of the subjects, match anything that is after dot, that part of the subject. So those are still at the API level when we talk about request reply and publish and subscribing. But when we're talking about the architecture of the system, it helps having more higher level abstractions. In this case, whenever we talk about sending a request and expecting a response, what we're talking about is a service. So we'll start calling this, starting from NATS v2, we call these services. Whereas if you have a sequence of events that are going to be consumed by an n number of consumers, we call them streams. And you can enable load balancing, of course, to either streams or services. But now we'll have this other level of abstractions which will help for, especially when talking about the isolation and the permissioning, about how to configure this because they work kind of differently. So for a stream, again, it's just a flow or just a sequence of messages that can be consumed and will be fan out. Whereas service is something that is expected to receive a request and then do something and return a result. And the recommendation is for this to always be load balanced. When using the accounts isolation features from NATS, for example, in this case, we have a couple of accounts. One is ACME and the CNCF, and we can see already how it helps having to use these abstractions for streams, where we say that the ACME account will export a stream named ACME, which is the greater, that is basically any event that is published after the greater than wildcard here. And the CNCF account can import from the ACME account into the ACME subject. with a import prefix to receive all the events. So now we can have a ticker, just publishing those events on this any subject after ACME, and then the subscriber on the CNCF account is going to be receiving those events. On the other hand, when we talk about the stream services, we say it is expected to have a response for that message. So in this case, we have a queue subscription for the hello subject that is going to be provided by the ACME account. And then the CNCF account can enable data sharing between those accounts by mounting that API or the hello API from the ACME account into the CNCF account. And so now under the CNCF account, you make a request on cncf.hello, and we receive a reply back from this producer or service on the ACME account. And all of these, another thing that made it into the NATS v2 are the flexible, became more flexible about the architecture that you can build. So one of the visions from NATS version 2 is that make it more flexible to expand across a single data center. The vision is to not have more silos and be able to connect NATS, use NATS to be able to connect everything. So they have more building blocks. You can use not only clusters that were part of NATS v1, you can have gateways to connect multiple data centers, and also have something called Leafnodes, which create extensions of a supercluster of a single cluster to have a hub and spoke type of topologies. So the classic NATS architecture was in v1 was to have, for example, let's say like a load balancer that is exposing a number of HTTP endpoints, and then behind that, use NATS for the internal communication using NATS services. And of course, that could be a highly available NATS cluster with if one of those go away, then if clients will reconnect and be able to find still continue to talk to each other by using failover into another NATS server. So the idea with NATS v2 is to have be able to expand not only from a single data center into multiple ones, have global deployments. So in this case, we have super clusters, which are cluster of clusters, and you also have the leaf nodes that can connect to a supercluster, either a supercluster or a cluster, and can also they can be a daisy chain as well. So you can have like very arbitrary topologies now. The superclusters are optimized for one network links and high latency. So where the cluster type of connections are meant to be in a single data center, the gateways are more like at most will give you like 3 hops from when routing a message from one cluster to another cluster in another region. And the leaf nodes allow you to extend these. We say that they are ideal for edge computing or IoT because you can delegate some of the work for the leaf nodes. For example, you can have a leaf node that is bound to localhost. So a device that can just start using a TLS is very constrained. I can talk to the leaf node, but the leaf node itself has a secure connection to the NATS supercluster and has credentials. So let's say, for example, we have in the pink dots, they are clients. They are connected to a leaf node. We can be sending messages from a region in San Francisco, and then it is going to make it across the gateway connection to, let's say in this case, it's going to be an Amsterdam cluster that we'll be building in the demo. But it is going through a leaf node and then receiving the message. So this client is not connecting directly to the supercluster, but to a leaf node connection. And in case there is no connection here, if it was a queue subscriber, then the message will be routed to another cluster that it can fail over to. In this case, for example, in Singapore. So let's build that type of topology using Helm in Kubernetes. So it's going to be actually two demos. One is going to be using gateways, connections between San Francisco, Amsterdam, and Singapore. And from the second demo, we're going to create the same, but using a supercluster for communicating across regions. So you'll notice that the difference between the configuration between these two deployments. So let's start with Helm. First, we have I already prepared a cluster in DigitalOcean where we have a couple of a few firewall ports open, 4222 for the NATS clients to connect, for 7422 for the Leafnodes, and also for the gateway connection, 7522. So first I'll generate the URLs for the gateways, and then I'm going to use it to create a Helm and YAML file that has each one of the endpoints explicitly defined. These are the external IP addresses for the nodes, because it is binding to the host port from each one of these kubelets. You could change these into using DNS, for example, or a node port if it's your deployment, which is actually recommended for production. So I will deploy this as external access. So let's deploy this, and in case you don't have it added already, you can add the Helm charts for NATS. Now we'll deploy into the 3 regions. And once it is deployed, we will create a stream, which is essentially a consumer of messages in San Francisco. San Francisco, it is running this IP right now. Now it's connected to San Francisco, and I'll send a message from Singapore. It's still not up yet. So let's wait a little bit. Okay, so you can see now the message got routed across different regions. If I make a quick telnet connection to this endpoint, you'll see that they're very different clusters. This is a cluster in San Francisco once again, and the connect URLs are basically when the client gets to be able to identify what are the other servers, brokers that it can use to fail over. When Singapore is a very different cluster, but still there's communication between these with the gateway connections. Now we will create a service instead. It's going to just reply with foo and send a request. Again from Singapore. You can see that you can make requests across from region to region. So this is not too difficult to set up, but it's a super cluster, so you involve like having to take into account the DNS, having this public external. All the gateways need to talk to each other because otherwise there would be partitions. But fortunately, if there's already a supercluster, you can use leaf node connections. So I already tore down this cluster, and just to compare, I'm going to create a leaf node based multi-region cluster that is just another supercluster to be able to stitch all those regions together. For this, you'll need credentials for that supercluster. In this case, I'm using an NGS supercluster, and I will use those credentials and connect as a leaf node to this other supercluster. So now I will deploy this with Helm. So you can see that the configuration is going to be simpler because you already are leveraging another supercluster for the communication between different regions. This one is still connected, so I'm going to disconnect it. Okay. Yeah. So now I will subscribe from, what is it? That's Singapore. No, San Francisco, and publish messages from Singapore. And there's communication using the leaf node connection. So I'm gonna make a service. The request response across regions. We can check from the logs. They're both connected to this NGS supercluster, which is just a supercluster. Yeah, that's what enables the routing. So, but the roadmap, there are a few things in the pipeline this year, notably the Jetstream, which is the reworking of NATS streaming. Message headers, which are, some of it has already merged in master, but still not released yet. There's a new work for exposing these service and stream APIs into the client. Also, incoming is MQTT support and more enhancement for monitoring, and zero trust security, and also in the future is more tight integration with WebAssembly. So that's it for my talk, and it's time for questions.